Hello everyone, it's me Sanjay Vasu back again with another video. This time I'm doing the Cambridge Lower Secondary Checkpoint Mathematics Paper 1 for April 2024. You're not allowed to use a calculator. Let's start. Question 1. Yusuf thinks of a number n. He adds 3. His answer is greater than or equal to minus 5 and less than 17. Write the correct inequality signs to complete the inequality. Well, his answer n plus 3 is greater than minus 5, greater than or equal to at least. So, we put this sign. Greater than or equal to will be on this side. The crocodile mouth opens on the side which is greater. And it's less than 17. So, less than and not equal to 17 gives like this. So, 17 is larger. And that'll be our answer, of course. Let's go to question 2. 200 to the power of minus 3 equals 1 by 200 to the power of w. Write the value of w. Well, 200 to the power of minus 3 is just 1 by 200 to the power of 3. That's 1 by 200 to the power of w. Now we can see easily that w is equal to 3 from this. That will be our answer. Let's go to question 3. X minus 2y equals 2, 5x plus 2y equals 58. Solve these simultaneous equations. Well, we can see that there's a minus and plus of 2y. So let's call these two equations 1 and 2. Let's just add these two up. That means 6x is equal to 60 because the plus 2y and minus 2y will cancel out. Therefore, x is equal to 10. Now we just substitute into the first equation. Now when we substitute this, 10 minus 2y equals 2. 2y is therefore equal to 10 minus 2, which is 8. And y is equal to 4. Now we have x equals 10, y equals 4. That's our answer. Question 4. Find the exterior angle of a regular 10-sided polygon. That's a regular decagon, but of course you do not need to know the name for this particular question. You just need to know that exterior angle will be 360 divided by n, where n is the number of sides. 360 by 10, 36 degrees. That's the answer. Question 5. Here's a sequence of calculations. 1 times 7 minus 2 times 1 is 5. 3 times 8 minus 4 times 2 is 16. And so on, 27, 38, 49. Complete the next calculation in the sequence. We can see that when we go from one answer to the other, we add 11. And what about the calculation numbers? It goes 1, 3, 5, 7, 9. So these are odd numbers. These are consecutive numbers. 7, 8, 9, 10, 11. So next is 12. And of course here, next is 11. Now over here, they are even numbers. 2, 4, 6, 8, 10. So next is obviously 12. And the minus signs are already given, so we just write 12 here. And 1, 2, 3, 4, 5, they're just a sequence of numbers. Next will be 6, of course. And, of course, over here, since we are adding 11 every time, we add 11 one more time to get 60 here. You can also do the calculation here. You'll anyway get 60. That's our answer. Question 6. A regular polygon has k lines of symmetry. Take the correct statement about the order of rotational symmetry of the polygon. Well, if a regular polygon has k lines of symmetry, let's take a square. It has 4 lines of symmetry. What's the order of rotational symmetry? In this case, of course, it's 4. Because every time you rotate the square by 90 degrees, that's 4 times, and you come back to the original position. But then, 4 times, it'll still be the same image. That's what rotational symmetry is. And since 4 lines of symmetry is equal to 4, so order rotational symmetry is k. That's our answer. Let's go to question 7. A. Mike and Pierre are each asked to write the equations of 2 lines that have a positive y-intercept. Tick to show if each student is correct or not. Well, a positive y-intercept means that in y equals mx plus c, c has to be positive. So over here, in Mike's equations, we have y equals mx, which is minus x, so m is minus 1, and then plus c, which is plus 3, and c is therefore equal to 3. So that's positive y-intercept. Now for this one, y equals 2 minus x, we can write that as y equals minus x plus 2. Now once again, m is equal to minus 1, and c is this time positive 2. But both equations have positive y-intercept, so Mike's is correct. Now what about Pierre? y equals x plus 0.5. Well, over here, y equals mx plus c. C is obviously equal to 0.5, and m will be 1. And c is 0.5, which is greater than 0, so it's positive. Now, for the second equation of here, y equals 7 minus 5x. We can write this as y equals minus 5x plus 7. Now, mx plus c, and that means m is minus 5, c is 7. 7 is greater than 0, so both are positive y-intercept, and that's our answer. Both are correct. Let's go to part B. The equation of a line is 7 equals 3x plus y. Find the gradient and y-intercept of this line. Well, we can make y the subject. So y is equal to 7 minus 3x. This is equal to, of course, minus 3x plus 7. And this is y equals mx plus c. Over here, m is equal to minus 3 and c is equal to 7. So the gradient is minus 3 and the y-intercept is 7. That's our answer. Let's go to question 8. Take to show if each conversion is correct or not. 60 nanometers equals 6 millimeters. Well, 1000 nanometers goes to 1 millimeter because you have to multiply by 1000 to go this way and divide by 1000 to go the other way. And yes, 60 nanometers is not equal to 6 millimeters because it's only dividing by 10, not 1000. Now 2000 gigabytes equals 2 megabytes. Well, 1 gigabyte is equal to 1000 megabytes. So obviously this is wrong, since when going from gigabytes to megabytes, you have to multiply by 1000, not divide, which is what they've done, so it's not correct. Let's go to question 9. Represent minus 2 less than x less than or equal to 4 on a number line. First, let's put two circles at minus 2 and 4. This is the place where the two numbers are. Now we can draw a straight line over here, and then since over here it's strictly less than with no equal to, we can leave the circle white. And on this side, it is less than or equal to. There is a possibility that it's equal to, so we have to fill in the circle. And well, this is our answer. Let's go to question 10. The diagram shows a shape made with three identical rhombuses. Find the value of x. Well, we can find this angle here because the three rhombuses are identical, and when we add all of this up, it's 360. Let's call this y. So 3y plus 3 times 70, 210 is 360 degrees. So 3y is 150 and y equals 50 degrees. Now, what is x? Well, rhombuses are parallelograms, and in parallelograms, adjacent angles add up to 180 degrees. So if this is 50 degrees, that means x will be 180 minus 50, which is equal to 130 degrees. That'll be our answer. Let's go to question 11. Gabriella collects the heights of 11 indoor plants and 12 outdoor plants. The table and incomplete back-to-back stem and leaf diagram show information about her results. A. Use the information in the table to complete the back-to-back stem and leaf diagram. Well, we can see that the modal height is 39 centimeters for the outdoor plants. That's the table which is given. So if the modal height is 39 centimeters, that means the most frequent height is 39 centimeters. At least one more should be at 39. So that'll be one here. Now how many are left? We have 8 already given, 1 we wrote, so there's 3 more left, because total 12 outdoor plants. Next, minimum height is 17, so of course we just add a 7 here. Now the range is 26. So the maximum minus the minimum, let's say maximum is x minus the minimum 17 is the range 26. So x is equal to 17 plus 26, which is 43. So we have to add one more here for 43. Well, of course, if we add one more 39 here, it still won't be the exact modal height because there's 2 of them. But then there's also 2 of 27. So we have to add another 39. And of course, this also brings the number of outdoor plants to 12. So we've completed the stem and leaf diagram. That's our answer for part A. Part B, calculate the range of heights for indoor plants. This is much more straightforward. The largest one is at the bottommost row, which is 30. And the smallest one will be at the innermost of the topmost row, 0, 7. 30 minus 7 is 23. That's our answer. Of course, it's in centimeters. Question 12. Work out the value of n to the power 4 plus 29 by n plus 7 when n equals 3. That means 3 to the power 4 plus 29 by 3 plus 7 is equal to 3 to the power 4 is 81. Now when you add this, it's 110 divided by 3 plus 7, which is 10, and that's 11. That's 13. A. Write 62,000 in standard form. Well, where is the decimal point in 62,000? The decimal point is here. How do we make this number? By moving the decimal point somewhere else, we have to make the number less than 10 and greater than or equal to 1. What number will come here which you can make? So if you move the decimal point 1, 2, 3, 4 places to the left, we'll get 6.2. So the answer will be 6.2 multiplied by 10 to the power of what? Well, since you moved it 4 places to the left, it is 10 to the power of 4. So that's our answer. Let's go to part B. Write 8.1 times 10 to the power minus 3 as an ordinary number. Since this is 10 to the power of minus 3, we move this decimal point over here 1, 2, 3 places to the left. So 0.0081. That'll be the ordinary number. That's our answer. Let's go to question 14. The diagram shows a shape made of 6 congruent equilateral triangles and a regular hexagon. The regular hexagon has an area of 140 centimeters squared. Calculate the shaded area. Well, we can see that the side length of the equilateral triangle is the same as the side length of the regular hexagon. So by definition, a regular hexagon is 6 times the area of an equilateral triangle with side length of that hexagon side. So if the side length here is x, that means this length will also be x there, x there. So it's basically 6 equilateral triangles with side length x. That forms the regular hexagon. So instead of having the area of 6 equilateral triangles, which is the hexagon, which is 140 centimeters squared, we need the shaded area, which is only 3 equilateral triangles. So 6 equilateral triangles area will be 140 centimeters squared, which is the hexagon. Now 3 triangles will be, because 3 is 6 divided by 2, we have to divide this side also by 2, 140 by 2, which is 70 centimeters squared, to get our answer. Let's go to question 15. The table shows information about the mass of each of 23 boxes. The mass in kilograms is shown over here. Part A. On the grid, draw a frequency polygon to show this information. Well, first we have 4 to 8 kilograms as the mass. Well, on the grid we have to draw a frequency polygon. So where do we place the dot to start the frequency polygon? It should be in the middle of 4 and 8. So let's make a new row to find the midpoints. So the midpoint of this class here, 4 and 8, will be 6. And for the others, we can also write their midpoints 10, 14, 18, and 22. Now these are the x values which we are going to use to label our graph. Now the y values. The frequency for midpoint of 6, frequency is 8. So we can label 6, 8 here with a cross. Then we have 10, 7, another cross. And do the same thing to find all the points in the frequency polygon. Now we have 5 points and we can just connect the dots to get our frequency polygon. That's our answer. Let's go to part B. Draw a ring around the interval that contains the median mass. Well, the median mass of 23 boxes will be the middle box. So if you arrange all the 23 boxes in ascending order, the one in the middle, right there, will be the box, which is the median. So what's the middle of 23 boxes? The number of the box will be 1 plus 23 divided by 2, which is 12th box. So the 12th box comes under this interval because the first 8 boxes come in the first interval and the 9th all the way to the 15th boxes comes in the second interval, and 12 is in between at 9 and 15, so of course it comes in this. That's our answer. Let's go to question 16. 1 by 9 is equal to 0.1 with the dot on top, which means 0.1111. Use this fact to convert 7 by 9 to a decimal. Give your answer correct to 3 decimal places. Well, 1 by 9 is 0.1 with the dot. So 7 by 9 will be 7 times 1 by 9. That's why we're given to use this fact. So 7 times 1 by 9 will be 7 times 0.1111, which goes on. So that'll be 0.7 with a dot on top, or 0.7777. Well, this is not our answer. This only gets you 1 mark, because the second mark comes from giving your answer correct to 3 decimal places. So we have to take this, and first decimal place, second decimal place, third decimal place is over here. Now the fourth one is also a 7, and that is of course greater than 5. So we add 1 to the third decimal place and the other two remain the same. So 0.778 will be our answer. Let's go to question 17. Jamila makes this sequence of patterns using white and black counters. A. Complete these sentences. The first one has been done for you. The number of white counters in pattern 4 is 15. Now in pattern 5 and pattern 100 we need to write the number of white counters. We can see that in pattern 1 there's 0 white counters. Pattern 2 there's 3. Pattern 3 is 8. Pattern 4 is 15. Well, we can see that if we add 1 to every single one of these, that'll simply become the sequence of square numbers. So this sequence here is a sequence of square numbers, or x squared minus 1. In sequence notation, that is, the nth term is n squared minus 1. So let's say pattern 1, n is equal to 1. So 1 squared minus 1 is 0, which is what we need. And the same thing for the others. So the number of white counters in pattern 5, using n squared minus 1 for the white counters, that'll be 5 squared minus 1, which is 24. Now the number of white counters in pattern 100, that's just 100 squared minus 1, which is 4 nines, 9,999. Part B, write an expression in terms of n for the total number of counters in pattern n. Well, we know that the white counters is n squared minus 1, and the black counters is, for pattern 1 we have 2, pattern 2 also we have 2, pattern 3 also we have 2, same for pattern 4. So it's just 2 counters which are black in color for every single pattern if this pattern continues. So in pattern n, we'll have n squared minus 1 plus 2. And that'll be n squared plus 1 counters. And that'll be our answer. Let's go to question 18. Question 18. Check to show if each of the calculations is equivalent to 37 times 10 to the minus 3 or not. Firstly, we have 3.7 times 0.01. Let's try to bring this calculation in the form of 37 times 10 to the minus 3. So let's make 3.7 into 37. We need to multiply 3.7 by something to get 37, right? So 3.7, in this case, multiply by 10 to get 37. So 3.7 is 37 divided by 10. 37 times 10 to the power of minus 1. And 0.01 is equal to 10 to the power of minus 2. Now this will become 10 to the power of minus 3, and therefore this is equivalent. The second one is 3.7 times 10 to the power of minus 2. Now this over here is the same thing as 3.7 times 10 to the power of minus 2. And therefore, this is also equivalent. Now the third one, 3.7 times 10 to the power minus 4. Well, 3.7 times 10 to the power minus 4 will be 37 times 10 to the minus 1 times 10 to the minus 4. That's 37 times 10 to the minus 5. And that's not the same thing as 37 times 10 to the minus 3, so it's not equivalent. And the last one is 37 divided by 10 to the power 3. That's the same thing as 37 multiplied by 1 by 10 to the power of 3, which is 37 times 10 to the minus 3. And this is therefore equivalent. Let's go to question 19. Point A lies on the y-axis and point B lies on the x-axis. M is the midpoint of AB, P is the midpoint of MB. Find the coordinates of point A and point B. We know that P is 60, 11, and B is on the x-axis. So if it's on the x-axis, that means the y-coordinate is 0. So we know that the y-coordinate is 0. So let's say that B is x, 0. Now, A is on the y-axis. So we can say that the x-coordinate is 0. So we can say that A is 0, y. Now, M is the midpoint and P is the midpoint of MB. So this will be half of MB, which is 1/4 of AB. And therefore, this whole thing, AP, will be AM, which is half of AB, plus MP, which is 1/4 of AB. So the whole thing will be 3/4 of AB. And that will be AP. And PB, so that means when we're going from A to P, the y-coordinate decreases from all the way from y to 11, and PB is equal to 1/4 of AB. So the y-coordinate of P, which is 11, will be 1/4 of the y-coordinate of A. So y of P will be 1/4 of y of A, which you have written as y. And that'll be 11. So y will be 44. This means that the coordinates of A will be 0, 44. So you got A down. Now what about B? Well, we can see that the x-coordinate of P is 60. And this is 3/4 of the way from 0 x-coordinate, which is A, all the way to the maximum x-coordinate, which is x. So the difference between B and A's x-coordinates will be x. And 3/4 of that distance is 60. So 3/4 of x is equal to 60, and x equals 80. Now since you know x is 80, we can say that b is 80, 0. So we know a and b, and this will be our answer. Question 20. X is an integer and 1 less than cube root x less than 2. Complete the sentences about x. One possible value of x is dash. Well, if the cube root of x is between these two values, that means the value of x will be in between two different values, 1 cubed and 2 cubed, and they are 1 and 8. So, since x is an integer, you can write the value of x as either 2, 3, 4, 5, 6, or 7. Any one of these 6 values. I'll just write 3. Now there's a total of dash possible values of x. 2, 3, 4, 5, 6, 7. As I said, these are 6 values. So there's 6 possible values of x, and that's our answer. Question 21. Point P lies on the line y equals 5 minus 2x. The x-coordinate of P is a negative integer. The y-coordinate of P is a prime number. Find a possible pair of coordinates for point P. Well, if x-coordinate is a negative integer, that means x is less than 0. Or x of P is less than 0. That means when we multiply this by -2, -2 times x of P, we'll flip the sign, but it'll still be 0. Why we flip the sign? Because we're multiplying by a negative number. So -2 times x of P is greater than 0. And when we add 5 to both sides of the inequality, we'll get -2 x of P plus 5 is greater than 5. And this is the same thing as the y-coordinate of P. So the y-coordinate of P has to be greater than 5. Now, the y-coordinate is a prime number. So let's just take the first prime number, which is greater than 5. We just let y of P equals 7. Now that means x of P we can find by just substituting into the equation here. So 7 equals 5 minus 2x. 2x equals minus 2, x equals minus 1, which is a negative integer, so it's correct. And therefore, x, or in this case x of P, is minus 1, and y of P is 7. There are many more points you can write. You can write minus 3, comma 11. There'll be minus 4, comma 13. And then minus 6, comma 17. And there are innumerable points, actually. But I've just written one of the pairs. And that'll be our answer. Let's go to question 22. Work out 8 by 9 plus 1 by 3 divided by 4 by 5. Give your answer as a mixed number in simplest form. So because of the rules of BODMAS, you have to do division before addition. So let's start with the division here. 1 by 3 will be 3 by 3 plus 1 by 3, which is 4 by 3. And then 4 by 5 will be 20 by 5 plus 4 by 5, which is 24 by 5. Now, we have the two values and we can divide. That'll be 4 by 3 times 5 by 24. And we can cancel some values to get 5 by 18. Now we have 5 by 18 and we have another value to add it with, 8 by 9. So 8 by 9 plus 5 by 18. And we can multiply the numerator and denominator of 8 by 9 by 2. Only then the denominators will be equal. So making this 18 for both denominators, this will be 5. And the other one will become 8 times 2, which is 16. That'll be 21 by 18. And we can simplify this to 7 by 6, dividing both numerator and denominator by 3. And writing in a mixed number is 1 by 6. That'll be our final answer. Let's go to question 23. A square has a side length of x centimeters. Mia enlarges the square by increasing each side length of the square by 200%. A. The side length of her enlarged square measures kx centimeters. Draw a ring around the value of k. Well, if Mia enlarges the square by increasing each side length by 200%, that means the total side length will be 200% of x plus 100% of x, which is the original x. So that'll be 300% of x, which is 3x. So if the side length of the enlarged square is kx, k will be equal to 3. Part B, find the percentage increase in the area of the square after enlargement. Well, at the start, before enlargement, the area is equal to x squared, because the area of a square is its side length squared. Now, after enlarging, the area will be, because the side length now becomes 3x, it'll be 3x the whole squared, which is 9x squared. Now the percentage increase will be 9x squared, the final area, minus the initial area, x squared, dividing by x squared, and then multiply by 100%. And that'll make 800%, and that'll be our final answer. That's also our final answer for this paper, since this was the last question. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.